So we're going to look at our last couple examples involving inverse trig functions. So let's say I want to find the integral of 1 over the square root of 3x minus x squared. So here we've got a problem. I do have an x squared there, but I have this 3x. So that's not just a constant. There's an x there, which means this does not match up with any of my formulas. So I'm going to have to take the denominator, 3x minus x squared. I'm going to rewrite it in descending order, negative x squared plus 3x. And we're going to have to complete the square like we did in our last video. So we've got a small problem though. This x squared has a coefficient of -1, so you're going to need to factor that out of everything, of your x squared term and your x term. So factor it out, -1. And now you're going to complete the square inside of your parentheses. So here is my coefficient, -3. So you're going to take your -3, take half of that, -3/2, and then you're going to square that and get 9/4. So that's what you need to put in right here is a 9/4. But you didn't really add in a 9/4 because of this coefficient of -1 here, right? When you distribute, you really put in a -9/4. So you need to offset that. You're going to add in a positive 9/4 now so that they cancel. Now this bit that's in parentheses here will now factor as x minus 3/2 squared. And maybe I'll rewrite it just so it doesn't lead off with a minus. All right, so we completed the square, which means we changed this denominator. Before it was 1 over the square root of 3x minus x squared. But that's the same thing as the square root of 1 over the square root, and it's 9/4 minus x minus 3/2 squared. So we've got to do a u substitution here because of this parentheses that's here. So u is going to be x minus 3/2, du is dx. So if I make my substitution now, this is 1 over the square root, 9/4 minus u squared du. And so now this will match up with the inverse sine function. If you look here, we need to identify our a. If that's a squared, then a is going to be the square root of that, which is 3/2. So I'm getting, this is arc sine of u over a, u over 3/2 plus c. And then you've got to plug in for u. So maybe I'll also flip this 3/2 into a 2/3, so I don't have to write a fraction here. And u is x minus 3/2 plus c. And there is my integral that I computed. All right, so let's look at one more of these. I'm going to call this a practice problem. I want to find the integral dx over 3x squared minus 6x plus 12. So this is a good opportunity for you to practice what we've done on the past two examples. So maybe what you should do is I suggest pausing the video and taking a moment and trying to compute this using what we did in the previous examples. So if you didn't pause it, you should do that now, but if you're not going to, I'm going to go ahead and go over how to do this. We need to complete the square again in our denominator. So if you notice, I have a coefficient in front of x squared, which means you need to factor it out of the first two terms. And I'm going to write the plus 12 on the end. Now you're going to complete the square inside. So look at b. Your coefficient of x was -2. You take half of that. You have -1, and then you square -1 and get a +1. So I need to put in a +1 here, but I didn't really put in a 1, right? What did I really put in? I really put in a 3. So I need to subtract 3 to balance out the change I made. And so now this will factor as 3x minus 1 squared plus 9. So we're going to plug that in, the integral. My denominator, let's change out my denominator for this new one, because they're equal. So now what I'm going to do is factor 3 out of the denominator. And now I'm going to do a u substitution here. U is going to be x minus 1. Du will be dx. And so I'm getting a 1/3, the integral, and it'll be 1 over u squared plus 3 du. And from here you can look back at your formulas and see that this matches up with the arctangent formula. Identify your a. So if I look here, this a would be the square root of that number, square root of 3. So in the end here, I'm getting 1 over 3, and I'll get 1 over the square root of 3, arctangent of u over a, which is square root of 3, plus c. So I'm getting 1 over 3 square roots of 3, arctangent, plug back in for u, it's x minus 1 over square root of 3 plus c. And there is my integral.